Okay, in this lab what we're going to be doing is combining barium hydroxide solid with ammonium nitrate solid. And our goal here is to make or simulate making a chemical cold pack as we do this. So procedurally, we need to set up our temperature probe, which we see right here, and connect that to veneer graphical analysis 4, which I have already done and is ready to go for us. So our next step is to get 33 grams of our barium hydroxide. So we'll be placing that on our balance, zeroing out the actual beaker, and then we'll be adding the barium hydroxide. We want somewhere between 31 and 33 grams of this. And there we have it. So it ends up being, look at that, 32 grams exactly. Okay, so we're going to go 32.0. Actually 31.99 is what it settled on. So 31.99 or 32.0, either are acceptable answers for the mass of our barium hydroxide. The next thing we need to do is get 17-ish grams of our ammonium nitrate. And I will zero the balance again. And we'll start adding the ammonium nitrate. And there we go. So we have 17.26 grams of our ammonium nitrate. Again, we have 17.26 grams of that ammonium nitrate that we'll be using. Okay. Next, our instructions tell us to take our temperature probe, put it in the barium hydroxide to get an initial reading and start collecting data. So we'll start collecting data now. We want to make sure that data is collecting, which I see the line coming across somewhere between 20 and 25 degrees Celsius. So then our next step is to add in the ammonium nitrate, which we will add that in. And then we now just simply stir. So we're going to stir for 3 minutes or until our data collection ends. One thing I am noticing with this, you can't obviously see this or experience this through the video, but this is letting off a very, very noticeable smell, which is the ammonium or ammonia gas coming off. It very much smells like smelling salts. It is not a pleasant odor. It is something that I would say stinks as I do this. And we're noticing that it becomes very liquidy as I'm doing this. We can kind of see that there's kind of a liquid nature to this as we continue to stir this. So we'll continue to stir as we run the reaction. We will also notice, as it is graphing this information, that we are seeing a very drastic drop in temperature. Okay, so we know this reaction is cooling down. So the products of this reaction must need energy to store as potential energy. So they're stealing it from the kinetic energy, and they are making this much, much colder. So we call this an endothermic type of reaction. And we see that, and it's supported by seeing this temperature drop inside of here. Okay. And we'll continue to collect data until the actual 3 minutes are up, so we can find our maximum temperature and our minimum temperatures by using the data that is being generated on the graph for us. Constant stirring helps us out because that keeps a nice consistent data collection. This temperature probe is very useful because without it, we would have to stop and read a thermometer every 10 or 20 or 30 seconds, which would disrupt our stirring. So by using this, we are able to collect the data, and it actually takes a temperature reading every second for us. So we're getting information pretty consistently, and we get a much better piece of data for us. Okay. So it looks like graphically we've kind of flatlined, and if anything, we're actually probably starting to warm up a little bit because obviously as this gets cold, there's ambient temperature in the room, and it's going to warm this thing back up to room temperature after the reaction has ended. So we can kind of see the graph growing here a little bit at this point in time. So I'm actually going to stop the data collection now. We could let it run. Oh, we'll let it run for 20 more seconds, and then it will automatically turn off, and then we'll use that information. And we'll use that data then to do our lab analysis. So what your job will be Oh, there's our bell. What your job will be to use the data that we see on the screen to find your starting temperature of our reaction, and then also find our minimum temperature. So if we come over here, we can use this data here to get our starting temperature. So we're seeing about 22.1 degrees Celsius is our starting temperature. And our minimum was way down here, probably right about here, and we're seeing about negative 19.9 degrees Celsius. So 22.1 degrees Celsius to 19.9 were our two temperatures. Our starting temperature, 22.1, and our final, or our coldest temperature of 19.9 negative, remember it's negative 19.9 degrees Celsius. And that is the data for this lab.